Hi everyone, my name is Ms. Connolly. I've been making math videos so that we can keep as many students learning during this crazy time. So today for math time, I would like to go over what's happening when we're dividing. Okay, and parents, you see that the way that we set up division is a little bit different than the way that we learned it back in the day. So we're not going to get into long division. That doesn't happen until 6th grade in Massachusetts. So I want to show you what's actually happening when we're dividing. We'll go over a couple strategies with a model, and then in following videos, I'll go over even more ways to think about division, okay? So this is just a little bit of an introduction with 3-digit divided by 1-digit division, okay? So we always wanna give our story problem a context, or not our story problem, our math situation. We would like to give the story problem context so we can keep track of all the moving parts. So what do we have here? I have in this model 154 oranges. Okay, so I have split that up into 15 groups of 10 and 4 ones. And what are we going to do with those oranges? We're going to split them equally. That's what we're doing when we're dividing. We're thinking about equal groups. We're going to split them into 7 equal groups. And our goal is to find out how many oranges are going to be in each of those boxes. Okay, so 150 oranges to start. 7 equal groups, how many in each group, okay? I'm going to be using multiplication to solve. We're going to be multiplying up with groups of the divisor. This is our divisor here. And then you're going to see what's going on and how the math matches the situation, okay? So it's going to be fun and exciting. I hope you are ready. So I like to draw a line down here to show my multiplication on this side, and then we'll get into what's going on over here. So I have 154 oranges, and I want to split them into 7 groups. We know that groups of 10 are easy for us to work with. They've been a friendly number since 1st grade. Okay, so we're going to be thinking about multiples of 10. It's not the only way to think about it, but it's the way that I want to show in this video to think about it. Okay, so what I'm going to do is I'm going to take this group of 10 here, and I'm going to put 10 oranges into my first box. Okay. Then I'm going to put 10 oranges in box 2, 10 oranges in box 3, 10 oranges in box 4, 10 oranges in box 5, 10 oranges in box 6, and 10 oranges in box 7. Okay, so far, what has happened? What has happened is I took 7 groups of 10. Let me say that again. 7 groups of, that's what the multiplication symbol stands for, 10. I took 7 groups of 10 oranges. I put 10 in each box. So how many oranges are in each box so far? 10. How many oranges have I used by distributing them into those boxes? I've used 70 oranges so far. Okay, so we see my 7 groups of 10. We see that that's 70 oranges. So I'm curious, how many oranges do I have left? Okay, you have this representation here to help you, but we could also subtract back to see how many are left. So when you are subtracting back and you have your numbers set up like this, the standard algorithm is something you might want to try. Is this the only way to record our work? Again, no. But is this the way I'm showing for this video? Yes. Okay, so next, we have 84 oranges left, and you can see the 80 and the 4 up here. Okay, what I want to think about is, could I make 7 more groups of 10? Could I pass out 7 groups of 10 again? Let's see. So I had 84 oranges. I know if I do 7 groups of 10, that's 70 oranges. So I'm thinking I have enough oranges. I think I could do another round of distributing 10 oranges at a time. And these are going to stick together, the model, so don't worry about that. So in each of my 7 boxes, I am adding another group of 10. And what you're thinking about is how many oranges are in each group. Okay, so let me record what I just did. Again, I did 7 groups of 10 oranges, and that meant that I used 70 oranges. And I'm thinking, how many oranges are in each box? Well, I see 10, 20, 20, 20, 20, 20, 20. There's 20 oranges in each box. Do you see that in the math over here? I did 7 groups of 10, and then I did 7 groups of 10 again. How many are in each box? There's 20 in each box, 20 oranges in each box. And right now, I see that over here. So what am I left with? I used 70 oranges again. And I know, and my representation shows that I have 14 oranges left. And it's beautiful when we get down to this, our basic math facts, when we can think about what is left and what do I do with it? And I'm sure that you've figured out that right now we have 14 oranges left. And I know that 7 times 2 is 14. So I can distribute 2 oranges to each box. Oh, I skipped a box. Hold on. I'm going to go back to it. We can take 2 oranges and give them. Oh, what happened to my orange? I don't know. Okay. I have no idea where that orange went. Learning how to use the app, that's fine. Oh my goodness. So, what's going on? I lost an orange, so I'm going to give it back to myself. I put 2 oranges in each of the boxes. So I just did 7 groups of 2 oranges, and that meant that I used 14 oranges. Do I have any oranges left? No, there's no oranges left. When you are subtracting down here in division, you're thinking about your story problem context, 154 oranges, and this number is always going to represent how many oranges you have left. Okay, in the next example, I think it's pencils, so it'll be how many pencils we have left. I'll go with that. So don't worry, I'll show you. So how many oranges ended up in each box? Well, here I have 22, 22, 22, 22, 22. And let me just circle what's going on now. Do you see the 22 in the math over here? Because first, we put 10 oranges in each group. Then we put 10 more oranges in each group. And then we put 2 oranges in each group. So how many fit in each box? 22 fit in each box. We thought about the groups of 10. That's always a nice way to start. How many groups of 10 can you fit in? Some of you might have recognized that you could have done 20 all at once. Some of you might have been saying, well, I know 7 times 2 is 14, so I know 7 times 20 is 140. I know that I have 154 oranges, so I could have done 20, 40, 60, 80, 100, 120, 140. Okay, so as we start moving along in division and getting a little more efficient, that might be something that you do all in one step. Okay, but as you know, there's so many different ways to get at math. So let's look at the next example. Okay, so next example, we have 128 pencils, and we are dividing these pencils equally between 4 classrooms. So again, I want to make 4 equal groups. And what are we looking for? How many pencils does each classroom get? So how many will be in each group? Okay, so let's get started. I want to say one more time, that I am doing this by groups of 10 and multiples of 10, but that's not the only way to attack this problem. So if you see this in a different way, feel free to do it your own way, okay? Just want to get everyone used to what's going on with division. So the last time I had put 10 in each group at a time. And so let me think about doing that this time and see if I could make a better decision. So I am trying to make 4 groups down here because I have 4 classrooms and I have 128 pencils. If I did 10 at a time into the 4 groups, that would only be 40 pencils. So that's going to take me a long time to do. So what I want to think about is how can I make this a little more efficient for myself? Okay. And maybe I want to think about doing 20 at a time. So what would happen if I did 20 at a time? How many would that be? That would be 30. Or sorry, what am I talking about? That would be 20, 40, 60, 80. Okay, so I'm going to think about that. And some of you might be thinking, Miss Conley, do one more group of 10, do one more group of 10. Okay, well, I'll do one more group of 10. So let me take this off. So what we see here is that we don't have to do 10 at a time. We can do several groups of 10 at a time. So we have a group of 10 fits there. Sorry, don't know why this is like that. A group of 10 could go there. And what I want you thinking about is how many is in each group and how many pencils did we use? How many did we give out all at once? There's that. All right, so what happened here? Well, I did do 4 groups of 10 at a time, but if I was thinking about it, I noticed that I could distribute 30 pencils to each classroom all at once. Do you see the 4 groups of 30? And how many pencils would that be? Let's double check. 30, 60, 90, 120. So we used 120 pencils all at once. If I had written down 4 times 10, 4 times 10, 4 times 10, that would have been a little extra work. Is it okay to do it that way? Definitely. So I was just wanted to show you a little bit more of an efficient way to record our work. Okay, so if I gave each classroom 30 pencils at a time, how many pencils do I have left to distribute? I have 8 pencils left to split evenly between 4 classrooms. And I think at home you're probably thinking, I know what to do. Okay, because we're using what we know about multiplication. So I say to myself, I have 8 pencils left. I have 4 classrooms to split it between. And I know that 4 times 2 is 8. So I'm going to go ahead and give 2 more pencils to each classroom. And don't worry about where they're sticking. They're just like to stick to each other. Okay, so what did I just do? I said I'm going to go to my 4 groups. I'm going to give them 2 pencils each. And how many pencils have I used now? I used 8. And remember the last example I said that this number represented the oranges? Well, right now we're thinking about how it represents the pencils. And when I subtract 8 pencils, I'm left with 0 pencils. And did you see the pencils go away? You did. Okay, so how many pencils did each classroom get? Well, first, I gave each classroom 30 pencils. Okay, we did that all in one step, thinking about groups of 10. Okay, and we could have recorded it over here as 10 at a time. Remember, there's many ways to do this problem. And then we gave each classroom 2 pencils. So how many pencils did each classroom get? The answer is here in our strategy. The answer is 32 pencils in each of those groups. And you can see the 32, 32, 32, 32. Okay, so that is an example of one way we can use multiplying up to help us solve. And we kept track of how many pencils we were using at a time. In this strategy, our answer is here. But is that the only way to do this? Let's look at one more. All right, so last one, and then I'm going to give you some to try on your own. We have 160 oranges, and this time, instead of me giving you the number of bags, I'm telling you how many are going to be in each bag. Okay? So I want to know how many bags does that make? So it's a little bit different of a situation. And I just want to show you that there's more ways to solve out there. So let's take a look. Okay? So we have 160 oranges. There's 50, 50, 50, and 10. That's how I split them up. Okay? And so what we're going to think about is if I take this 50 over here, if I do this 50 divided by 5, will that give me the same number of bags as this 50 divided by 5? And will it also give me the same number of bags if I do 50 divided by 5 over here? And then I have 10 divided by 5 over here. Okay, so this is just one other way of thinking about it that I want to make sure that I expose you to. Okay, and you can always choose whatever works best for you. So let's think about this. We have 50 oranges in this pile over here, and I'm going to put 5 in each bag. And my goal is to find out how many oranges are going to be how many bags I can make if I put 5 in each bag. So let's see here. This stack of 10, so far I have thought about if I put 5 oranges in each bag, so far I've made 2 bags, okay? And then I am going to think about it again. There's 3 bags. We made 4 bags. And I think you're probably predicting how many bags we can make. There's 5 bags, 6 bags. I don't know why that one's down there. 6 bags here. We're going to make 7, 8, 9, and 10. Okay, now some of us are probably thinking, I don't need the representation for that. So you might have already been thinking to yourself, Ms. Conley, why are you doing all this work? You knew that 50 divided by 5, if I took 50 oranges and I put 5 oranges in each bag, you knew I was going to get 10 groups. Okay, so if you know that, then you know that this group of 50 divided by 5 is 10. And then you know that this group of 50 divided by 5, 50 divided by 10 is 5. So what I'm seeing is that I know that in the first 50, I would make 10 bags. In the second group of 50, I could make 10 more bags. And in the third group of 50, I could make 10 more bags. So with these 50, 100, 150, I know so far that's 30 bags. And then I just have the last 10 over here. And you're probably saying, I know 10 divided by 5, and that's 2. So what we have here is, I know that 150 divided by 5 is 30. 10 divided by 5 is 2, so we have 32. So how many bags of 5 could I make if I had 160 oranges? And so what I thought about this time was I thought about the dividend, 160, and if I split that into groups of the divisor, I was like, well, I know that I could do 50 divided by 5, and I know that. And I know that I could do 50 divided by 5 again. And I knew that I could do 50 divided by 5 again. And when I add all of those up, I know that I have 10 plus 50 divided by 5 is 10 plus 50 divided by 5 is 10. It's kind of like multiplication when you split up numbers and do it this way. So we split it up. All these things come in together. And you see the 32 groups of 5 that I could make because I split up my dividend into groups of this, my divisor, and I made the problem a little bit easier to deal with. So that is another way you can solve. So here's a bunch for you to try. I want you to think about 162 divided by 6. I want you to think about 104 divided by 4. And I want you to think about 128 divided by 8. Okay? Put those on your paper. Give it a try. If you're working on the computer, you can try going to this website and manipulating the groups of 10. Okay? Make sure you check out the next videos because we're going to get even deeper into division and we'll talk about 4-digit divided by 1-digit. We won't be using the base 10 blocks, but we'll have some other representations that'll help us. Okay? Bye.